Scatterplot plays a major role when you analyze data in statistics. What is Scatterplot? Scatterplot is a graphical representation of bivariate data. What is data? So let's say you are attending a class meeting today. Your instructor is taking attendance at the beginning of the class. What do you expect to see on the attendance sheet? So let me tell you this. In a typical attendance sheet, there are a couple items. So first is your name, and then your student ID, and then your attendance, right? So we have your student ID, your name, and your today's attendance. So your student ID is your ID, and then your name is just your name, right? And then what about attendance? So what kind of data do you expect on the attendance? So attendance is either present or absent. So let's say we have 40 students in a class. I expect to see 40 ID, 40 names, and then after I finish taking roll, I expect to have 40 attendance, right? So for each person, the status is either absent or present. So data, this attendance sheet is data. So in other words, data is information. So what about bivariate data? Bivariate data is a set of data that has two variables. So go back to the attendance sheet that I just mentioned. I mentioned student ID, your name, and your attendance, right? So I already mentioned three variables. The first one is your ID, the second one is your name, and then the third one is your attendance. But bivariate data, we only consider two variables. So let me give you an example of a bivariate data. So the following data contains the score of final exam and research paper of 8 students in my statistics class. So this is a bivariate data because there are two variables. The first one is final exam score. The second one is research paper. So final exam score, let's take a look at the data. So data, how many students are there? There are 8 students, right? So in the data, you expect to see 8 rows. The first student got 72 points on the final and got 65 points on a research paper. So this is one student's information. And then the second student got 75 points on the exam and then 70 points on the research paper. This is the data for second student. And then the third student, 79 points on the final and 79 points on the final and 75 points on the research paper. All right. So how do we build a scatter plot? To build a scatter plot, we have to plot every student's information on a picture. So let's start. So the first student got 72 points on the test and then 65 on the paper. So how do we handle that? So do you see that on the right hand side, I prepared two axes for you. On the horizontal axis, I call that final exam, and then on the vertical axis, I call that research paper, and I already scaled the two axes for you. Okay, so the first person has 72 points. So where is 72? 72 is a little bit more than 70, and then 65 point is right on the vertical axis. So here is how we plot the first point. So 72, 65. So the first point is right here, and then you can call this a 72 comma 65, just like x comma y. So this is one student. And then the next student is 75, 70. So the next student is right here. So this point stands for the second student. So x is equals to 75. The x, I will just call that final exam because we are talking about data, right? We are not talking about x and y. So when you sketch your scatter plot, you have to label the horizontal axis and the vertical axis, because if you don't label them, we don't know what are you talking about. Right? So for the horizontal axis, if you don't say the words final exam, I don't know what 70 is. I don't know what 75 is. Since you have final exams written there, I know that 70 means 70 points on the final. When you do data in statistics, you must label the graph, right? And then the next student, 79 points on the final, and then 79 on the final, so that is a little bit less than 80, and then 75, so that will be right here, because this corresponds to 75 on the research paper, and then 79, which is right here on the final. All right. So that's the next point, 79, comma 75. So this is a 79, comma 75. And then the next person is 81, 80, right? So 81 a little bit more than 80, and then 80. So that is around right here. So that is 81, 80. And then the next person got 84 points on the final, and then 98 on the paper. So 84 is a little bit less than 95, and then 98 is all the way up right here. So this is 84, comma 98. And then the next person, 86 points on the final, and then 70 on the paper. So that will be 86 and then 70. So 86 is around right here. So look at my yellow dot. 86 is around right here, and then 70 points on the paper is right here. So let me go ahead and draw that dot for you. So that is right here. This is 86, comma 70. And then the next person is 90 on the test, 80 on the paper. So 90 is right here, exam, and then 80 on the paper. So you go up to 80. So this is where the point is, 90, comma 80. Right here. So this is 90, comma 80. And then the last person is 94 points on the test, 94 points on the test, and then 96 on the paper. So 94, and then you go all the way up to 96. So that is around right here. So this is 94, comma 96. So after the job is done, and then you can see you should have 8 points on the scatter plot. All right, so this is a graphical representation of bivariate data. Bivariate means two variables, final exam score and research paper. And then after this, I would like to introduce a few more keywords to you. So let's take a look at this. So the horizontal axis is the x-axis, and then the x-axis is for the independent variable. And then independent variable is a language that you use in algebra. So this is the language that you use in algebra. And then independent variable has another name in statistics that is called explanatory variable. It's a language that we use in statistics. And then in this bivariate data, what is our independent variable? Our independent variable is final exam. And then what about the vertical axis? The vertical axis is dependent variable. In statistics, we call that response variable. So in this bivariate data, the dependent variable is research paper. And then in algebra, we use x and y. So why do we call them independent and dependent? Because in algebra, we say the value of y depends on the value of x. So put that language in this bivariate data, we say that the value, or I should say your paper score, depends on your exam score. And then in statistics, this is the language that we use. We say that we use the response variable to study the behavior of explanatory variable. So using this data, we are using your final exam score to study your research paper score. So there are two variables in this data. One is the final exam, the other one is research paper. I am trying to use people's exam score to study the behavior of research paper. So questions like this can be, if you get a very good scores or very high scores on the final, is that means you get a very high score on the paper? Another question can be, if you have a low score on the exam, is that means you have a low score on the paper? So we can answer questions like this in statistics. So one example is never enough. So let's do another example. So we have another example right here. This is another set of bivariate data. There are two variables. So let's read the description first. The following data contain the number of complaints and quality rating of 10 coffee shops in a city. So we have two variables. The first one is the number of complaints, and then the second one is quality rating. So let's take a look at the data. The first one, the first row, 0, 10. So that represent one coffee shop. all right, one coffee shop. That coffee shop has no complaint and 10, and the quality rating is 10. And then another coffee shop, which is in the second row, has 2 complaints and the quality rating is 6. And then the third shop has 10 complaints and then the quality rating is 1. What does that mean? That means people complain this place all the time and then the quality is very low. In the first row, no one complain and the quality is very high. And then in the second row, people complain a little bit, so that might reduce the quality rating. And then the fourth row, that coffee shop has 3 complaints and the quality is pretty good, 7 points. All right, so what I'm trying to do is I'm trying to graph this data. So let's start at the first one. Let's use another color to give you a better contrast. So the number of complaints, I call that the X, and the quality rating, I call that the Y. So that means I am going to put the number of complaints in the horizontal axis. So let's take a look. Horizontal axis, I have number of complaints right here, right? So that goes to the horizontal axis. And then the quality rating, that goes to the vertical axis. Okay, so 0, 10. So let's graph 0, 10. When complaint is equals to 0, the quality is 10. So here is the how we do it. We find 0 in the complaint first, which is right here in the origin. And then the quality rating is 10. So you start at 0, complaint, and then you go up to quality rating 10. So the first point is right there. So let's put it right here. So this is 0, 10. So that is the first shop. And then the next coffee shop, number of complaint is equals to 2, quality rating is equals to 6. So complaint is equals to 2. We start at X, the X-axis or the horizontal axis equals to 2, and then the quality rating, you jump up to 6, which is right there. So that is 2, 6. All right, so this is 2, 6. And then the next one, the complaint is 10. So the complaint is 10 right here. And then the quality rating is 1. So that is right over there. And then you just put 10, 1 right here. So 10, 1. 10 complaints, quality is 1. And then the next shop, X is equals to 3, or complaint is equals to 3. So complaint is equals to 3, and then quality rating is equals to 7. So that is around there. So this is another coffee shop, 3, 7. And then the next one, complaint is equals to 5, rating is equals to 7. So complaint is equals to 5, starting right here, and then you go up to 7. So that is a 5, 7. 5, 7. And then the next one, complaint is equals to 6, rating is equals to 4. So complaint is equals to 6, rating is equals to 4 right there. So complaint is 6, rating is 4. So this is 6, 4. And then the next one, complaint is 4, rating is 9. So you start at horizontal X equals to 4, and then you go up to 9 right there. This is 4, 9. And then the next one, complaint is 1, quality is 8. So you start at the horizontal axis, complaint is 1, and then you go up to 8. So this is 1, 8. And then the next one, 7 is complaint. So 7 is complaint, that is right here. And then you go up to a 5. 5 is there. All right, let's draw a dot. So this is 7, 5, almost done. The last one is X equals to 8. So we have 8 complaints, and then the quality is 3. So 8, 3, that is right there. So 8, 3. 8, 3. All right, so you have 10 dots. So each dot represents one coffee shop, and then this is the scatter plot. All right, so since we put the number of complaint in the horizontal axis, so that means the number of complaint is the independent variable. That is the language we use in algebra. In statistics, we call the number of complaints explanatory variable. And then the vertical axis, we put quality rating, so that is dependent variable. in algebra, in statistics, we call that response variable. And then since we are using explanatory to study response, so in this problem we say that for each coffee shop, we use the number of complaints they receive to study the behavior of their quality rating, right? So we use the actually I wrote a mistake in here. I said we use quality rating to study the behavior of complaint. All right, let's quickly fix that. So let's cross this out. Let's fix this. So we are using the number of complaint to study quality rating. All right. Oh, rating. Okay, so that just fixed the mistake, and this is also the end of this video. If you think my instruction is helpful, let me know in the comment below. Like the video, share the video for me, subscribe to my channel if you haven't done so. I appreciate your help and support. I will see you all in the next one. Signing off for now.